Okay, students, good morning. The next topic, trigonometric ratios of some specific angles. You can find the values of trigonometric ratios for some specific angles only. For some specific angles. For which angles we can find the values of the trigonometric ratios means already we know how to construct that 30 degrees angle, 45 degrees angle, 60 degrees angle, 90 degrees angle. Okay, so for those angles we can find the values of the trigonometric ratios. Okay, so of course for 0 degrees also we can find here. Okay, so how we can find the trigonometric ratios of 45 degrees angle? Find the trigonometric ratios of 45 degrees angle. Okay, so the meaning of thing, how can you what is the value of sine 45 degrees, what is the value of cos 45 degrees, tan 45, cosecant 45, secant 45, cot 45. So we'll find the values of that trigonometric ratio at the angle of 45 degrees. Okay, so to find it, first of all we can draw a right angle triangle. What is it? Right angle triangle. So in that right angle triangle, one angle is to be 90 degrees. Here we assume that the angle B is 90 degrees. Then the remaining two angles are to be acute angles. Okay, here we are taking angle A is equal to 45 degrees. Angle A is equal to 45 degrees. For example, in the right angle triangle, one of the angle is 90 degrees, the remaining two angles sum is equal to 90 degrees. We know that based on the angle sum property. So what is the angle sum property? Sum of the three angles in a triangle is equal to 180 degrees. The meaning of a thing, angle A plus angle C plus angle B is equal to 180. One of the angle B is 90 degrees, then automatically sum of the remaining two angles is also to be equal to 90 degrees. If we can assume that one of the two angles is equal to 45, must and should the third angle is also, the second angle is also to be 45. Why? Because sum of these two is 90 degrees, means if it is a 45, the remaining thing is also to be a 45. Okay, here we took that angle is to be a angle B, right angle triangle. Angle B is 90 degrees, angle A is 45. Automatically angle C is 45 degrees based on the angle sum property only. If two angles are to be 40 equal, if two angles are to be equal in a triangle, that is an isosceles triangle. Already we know that is an isosceles triangle. Already it is to be 90 degrees, so right angle. And one more property is also to be satisfied for the triangle, that is isosceles triangle. Then it is called as an isosceles right angle triangle. Isosceles right angle triangle. In that isosceles right angle triangle, two angles are equal and its opposite sides are also to be equal. Two angles are equal. Here the two angles are to be angle A and angle C, and two opposite sides are also to be equal to the equal angles. Which are to be opposite sides to that equal angles? For A, opposite side is to be BC. That measure is also to be equal to that opposite angle of equal angles. Angle C, opposite side of equal angles. Angle C opposite side is to be AB. Meaning of that, BC is equal to AB. BC is equal to AB. Okay. Coming to that, let in triangle ABC, angle B is equal to 90 degrees. What is that? Angle B is equal to 90 degrees. Then angle A is equal to angle C. That means the result is equal to 45 degrees. What is the result? 45. Okay, so we assume that here one of the angle is 45, then automatically the second angle is also to be 45. Then A opposite side is to be BC, C opposite side is to be AB. So then BC is equal to AB, then isosceles triangle. It is an isosceles triangle. Based on that, we say that these two sides are also to be equal. We can assume that BC and AB measures are equal to each other, and that measure is equal to A units. Okay, we can assume that that is to be A units only. BC is equal to AB is equal to A units. So means we know that BC measure, means we assume that BC measure and AB measure, those are to be equal to that A units. So then based on that we can find the value of AC, means length of the side AC. Okay, so by using the Pythagoras theorem, by Pythagoras theorem, hypotenuse square is equal to side square plus side square. Okay, so what is the hypotenuse here? AC square, that is equal to AB square plus BC square. AB square is A square, BC square is A square in our assumption. A square plus A square is 2A square. Then AC square is equal to 2A square. AC is equal to square root is to be transposed to that side to be changed as a root 2A square. Okay, divide that as root 2 into root A square, square root cancel, the balance is to be root 2 into A. This is the length of AC line segment. What is the length of AC line segment? Root 2a units. Okay, so just I note it as that ABC triangle, angle B is equal to 90 degrees, angle A is 45, it is also to be 45. Just will mention here only, that's enough. It is A units in our assumption, it is also to be A units in our assumption, then it is to be root 2a units based on this A units. Okay, root 2a units. Okay, so now so we'll write the values of that 45 degrees for the trigonometric ratios. Okay, so using the definitions of the trigonometric ratios, sine 45 degrees, where it is a 45 here, it is a 45. So for this 45, sine formula means opposite side by hypotenuse. What is the opposite side for this? BC. Hypotenuse is AC. For 45 degrees opposite side is BC. For hypotenuse is to be AC. Means BC by AC. BC by AC. What is the BC measure? A by AC measure root 2A. A1's cancel. Numerator balance only 1 by root 2. 1 by root 2. A1's like this. Okay. So 1 by root 2. Coming to the cos 45 degrees, the formula for the cos is to be adjacent by hypotenuse. It is adjacent for 45 degrees. It is a hypotenuse. What is the adjacent here? AB. Hypotenuse is AC. AB measure is A by AC measure is root 2A. A1's, then the balance is 1 by root 2. Here we observe one thing, sine 45 degrees is 1 by root 2, cos 45 degrees is also to be 1 by root 2. Okay, so 45 degrees value of for sine and cos is to be same. Okay, 1 by root 2, 1 by root 2. Then coming to the tan 45 degrees, already we know one formula. Tan formula is to be sine by cos. We know that sine by cos means tan 45 is equal to sine 45 by cos 45. What is the sine 45? 1 by root 2 by cos 45 1 by root 2. 1 by root 2 1 by root 2 cancel, the result is 1. Other than that, what is the formula for the tan 45 degrees? Opposite side by adjacent side. Opposite side by adjacent side. What is the opposite side for this? BC by AB. BC by AB means A by A by A1's 1. Okay, whatever the procedure you can follow that. Getting the result is used to be same. Okay, if instead of that, if we can assume that is to be 45, if C is 45, then so sine 45 means what is the sine 45 value? Opposite side by adjacent formula. Sine opposite side by hypotenuse. What is the opposite side for the C? A by hypotenuse is root 2A. A by root 2A. A cancel, the result is to be 1 by root 2 only. Whatever the procedure you can follow, getting the result is to be same. Tan 45 degrees is 1. Then coming to the cosecant 45 degrees. What is the cosecant 45 degrees? That is equal to, it's a reciprocal of the sine. 1 by sine 45 degrees. 1 by sine 45 degrees. What is the sine 45 degrees value? 1 by root 2 means 1 by 1 by root 2. 1 by sine 45. 1 by root 2. So write it as that root 2 only by interchanging that to the numerator. Okay, then coming to the secant 45. Secant is a reciprocal for cos. Reciprocal for cos means 1 by cos 45. 1 by cos 45 means 1 by root 2. Again to be same means cosecant 45 and secant 45 are to be same. Cosecant 45 and secant 45 are same. Sin 45, cos 45 are same. Then coming to that cot 45. The balance is to be cot 45. Reciprocal for tan. 1 by tan 45. 1 by tan 45 means 1 by tan 45 is 1. 1 by 1 is 1. Okay, cot 45 degrees is 1. Means tan 45 degrees and cot 45 degrees is to be same, equal to 1. Cosecant 45, secant 45 same. The result is equal to root 2. Sin 45, cos 45 are same. The result is equal to 1 by root 2, 1 by root 2. This is the way to find that 45 degrees angle, trigonometric ratios of 45 degrees angle. Okay, then